Yep. All right, here we go. We're going to do some limits graphically today. So let's just look at this function here. We have the graph of y equals f of x, should be labeled, right? We've got a y-axis, our x-axis. I actually clarified a couple of things here. There's a vertical asymptote at x equals 2. There's a horizontal asymptote at y equals -3. And even though it doesn't look like it, we're going to say there's a horizontal asymptote at the x-axis. In other words, y equals 0. So in other words, as the curve comes down here, it's going to get closer and closer to the x-axis, but it never actually will touch it, even though it looks like it kind of does. Okay. The other thing I want to clarify as well is this point here, 3, -1, that's actually a point not on the graph. All right, so it's just like we're labeling the nothingness, if that makes any sense. I know that could be somewhat confusing, but this came straight from the AP College Board, so I'm going to leave it labeled, but understand that we're labeling the whole. So there's the output. There is no output for when the input is 3. All right, so with that said, let's get rocking and rolling here. So the first one is going to be the limit of f of x as x goes to -2, and I kind of want to visualize these. I'll do the first one in colors to help with that, but then the rest I'll probably just do all in black just to save some time. So here we go. So this is red. Limit of f of x as x goes to -2 from both the right and the left. So the way you do a limit is you first look at it from one direction. So as x goes to -2 from the right. So in other words, as your inputs get closer and closer and closer to -2 from the right, what are your corresponding functional values getting close to? Right? And we thought of this as x gets closer and closer and closer to the right, right? There's this little limit buggy, right? Silly little concept that's going to track along the curve. What unique y value would he be approaching? Well, it looks like he's going to be approaching this y value, which if I go over, appears to be like 0.5. Now, you can't just look at it from the right, right? So it's not okay just to look at what's going on from the right. You also have to look on what's going on from the left. All right. So as my inputs get closer and closer and closer to -2 from the left, what are my corresponding functional values getting close to? Right. So that's like the silly little concept of the left-hand limit buggy. So as x gets closer and closer and closer to -2 from the left, what unique y value would he be approaching? And he's approaching the same y value, right? All right. So it's going to be 0.5. So we would say that the limit here is going to be 0.5. And I know you might be saying, how do you know it's 0.5 and it's not 0.4? It'll be a lot more obvious on any test that I give you. But, if you said 0.4, I would have gave you credit because you got the idea, right? I'm not splitting hairs over here of what this actual y value is. It's the idea that they're approaching this y value, okay? All right, so that's that guy. So let's take a look at the next one now. So the limit of f of x as x goes to 5, and this little superscript plus after that means not +5, but it means as x goes to 5 from the right. So 5 I have to kind of chuck in on the graph here because it wasn't labeled, right? And I'm going to kind of just note what the y value is here, right? Because that actually helps you out a lot when you do the limit, since that's what we're looking at, what we're approaching, right? So now we're only approaching the input of 5 from the right. So as my x values, as my inputs get closer and closer to 5 from the right, what are my corresponding functional values approaching? So, right, that little limit buggy that's tracking on the curve, what y value is he approaching? Well, it's going to be approaching that y value, which if I go over here, looks to be like -2 and some change. So -2.25, we'll say. All right. Now, I'm kind of making that up, right? I don't know exactly what it is, but that's not the idea. The idea is that you didn't say -7 or you didn't say 5 for the answer, right? You have an idea that this y value, whatever that is going to be the limit, right? And I kind of did that intentionally. All right, so let's go now to the next guy. Let's do the limit of f of x as x goes to 2. And since there is no indication from the right or from the left, we assume it's from both sides. So here's x equals 2 right there. So now I have to approach this from both sides. So, all right, as x goes to 2 from the right, what are my corresponding functional values getting close to? So this is kind of interesting. The closer and closer and closer I get to -2, it looks like the corresponding y values are going up. And the closer I get to -2, the bigger they're going to be. Because remember, we said this is a vertical asymptote. So we never actually cross this thing. All right, so I never actually get to 2. I approach 2. And as I approach 2, my little limit buggy who's tracking along the curve here, he's going to be going up forever. So there's no unique answer here. All right. So now, all right. So let's see what's going on with the left. Well, as I go to -2, not -2, but as I go to +2 from the left, right, my corresponding functional values are doing the same thing. They're going up forever. That little buggy that's tracking on the curve, right, from the left is going up forever. So it seems like that both from the right and the left, my y values that I'm approaching are getting bigger and bigger and bigger. So we're saying that we're approaching positive infinity. Now, I know it's a little weird to say something equals infinity. Remember, infinity is not an entity, it's an idea, this idea of growing without bound. All right. So remember, limit is something that we approach. So when we write the limit equals infinity, it's kind of okay because we're saying the y value that we're approaching is going to be this huge positive number. Okay. So now, believe it or not, this is a fancy way or a descriptive way of saying that the limit does not exist. So now that's the second example I have given to you this year so far of when a limit cannot exist. One is when the limit from the right doesn't equal the limit from the left, and the other now is if the limit is growing without bound, right, and it's tending towards, say, a positive infinity or maybe even a negative infinity, that's just a fancy way of saying does not exist. So you might say, well, could I have put does not exist? Would that be an acceptable answer? And it is an acceptable answer, but it's not the best answer, all right? This is a better answer because not only are we saying it doesn't exist, but we're also telling you, giving you some information that it's actually going towards positive infinity. All right, so that's a pretty big deal. All right, moving on to this now, you have to look at this and recognize that this is not a limit question, right? This is something you learned in pre-calculus and in Algebra 2, okay? This is a functional value question, and all I'm asking here is what is the output when the input is 2? So in other words, what's the functional value at x equals 2? And since there's an asymptote here and there's no dot on that asymptote, right, there is no y value at x equals -2. So we would say that the functional value is not defined or undefined. Could you say it does not exist? And yeah, you could. It's just for whatever reason, typically when limits don't exist, we say the limit does not exist. And when there is no functional value associated with an input value, we typically say it's not defined or undefined. All right, it's kind of semantics, but that's how we're going to proceed moving forward. All right, so let's move on now to the limit of f of x goes to 3. All right, so I'm going to actually erase some of this slop a little bit so it's somewhat clear. All right, so let's get rid of this stuff here. Get rid of that. Get rid of that. Just clean it up just a little bit so the diagram's not too messy. All right, so here we go. So now we're going to 3. So again, there is no indication of from right from left. We assume it's from both sides. 3 is right here. Remember, I started off by saying this is a little confusing because this almost leads you to believe that 3, -1 is a point on the graph, but it's actually a point not on the graph. They're labeling this hole here. So there is no functional value at x equals 3. So now let's do the limit. Like, oh, maybe the limit doesn't exist, right? There's nothing there, right? So maybe some of you saying, not listening and just glancing over are like, all right, hey, all I have to do is look at the y value and that's the limit, right? So no y value, there's no limit. And that would be wrong. So let's see why. So let's go through the process, right? If I'm approaching 3 for both sides, let's start from the right. As x goes to 3 from the right, what are my corresponding functional values approaching? What are they getting close to, right? Think about that little limit buggy from the right tracking along the curve. He's getting close to something as he gets closer and closer and closer and closer and closer to that hole. He's getting closer to whatever that y value here is. And since they were nice enough to label that y value for us, that hole, we know that the limit from the right, this little limit buggy, is approaching -1. Likewise, as I approach 3 from the left, my corresponding functional values, right, or my left-hand limit buggy is going to crawl along the curve. He's also going to get closer and closer and closer to that hole, much like the example I gave you when I got closer and closer and closer to the wall by having the distance, right? And that y value, that unique y value that I'm approaching, remember, a limit is what you approach, would be -1. So the limit is -1. So just because there's no functional value at 3, right, did not affect the fact that there was a limit as x went to 3. It's a real big deal. All right, so now let's go back to review time. F of 3. This is not a limit question. This is a functional value question. When the input is 3, what is the output? Now you might, again, and I almost would understand it, kind of. This is confusing how this is labeled. You might say, oh, the answer is -1, but it's not -1. Remember, we're labeling the hole here. There is no output. There's a hole there. So when x is 3, there is no output. So it's undefined or not defined, all right, because it's a functional value question. Okay. All right, moving on to 7. So now take a look at these guys. Now we're approaching an infinity. Haven't given you these yet this year. So this says the limit of f of x as, let's do 8 first. Limit of f of x as x goes to positive infinity. What the heck does that mean? Well, think about it. As your inputs go to positive infinity, in other words, as they go to the right forever, what are your corresponding functional values approaching, if anything? Right? So that little limit buggy that's tracking along here, as we go this way forever, are the y values getting close to something? And the answer is yes. Since there's a horizontal asymptote, we know that the bigger we make x, the closer we'll get to that asymptote, all right, which is a y value of -3. And so we would get -3 there, okay? If there was no asymptote, if it was just going down forever, then the limit buggy would go down forever. He would approach negative infinity, which would be a fancy way or descriptive way of saying does not exist. Now notice this limit is really a one-sided idea because you can't approach infinity from two sides, right? You're only approaching infinity basically from the left side because you're going to the right forever, right? Reverse concept is, well, then what about the limit of f(x) goes to negative infinity? So in other words, let's go to the left forever. So as my x values go this way forever, what are my corresponding functional values approaching? Is there some unique y value that they're getting closer to? And again, since I told you there was a horizontal asymptote at y = 0, the closer I go here, the further left I go, the closer I'm going to get to a y value of 0. Okay? So there you have it. All right, now let's take a look at this last example here. Looks like I don't have to erase anything. Limit of f of x as x goes to 0. So 0 is right here. As x goes to 0 from the right. So as I go to 0 from the right, what are my corresponding functional values getting close to? What are my little functional buggy? What's he tracking to? Looks like he would be getting close to tracking to this y value, which is 1. So now let's do the limit of f of x as x goes to 0 from the left. So now I'm on the other side. So what are my corresponding functional values getting close to? Now you might say, oh, there's a dot here, it's filled in, so the answer is still 1. But remember, a limit has nothing to do with the functional value. It's what you're approaching. So as x is going to 0 from the left, my little left-handed limit buggy, he's crawling or tracking along this curve. He's getting closer and closer and closer to whatever that y value is there, which it looks like that y value is 3. All right, and now 11, this question is really answered for you. This says the limit of f of x as x goes to 0 from both sides. Well, you just did from the right and from the left, and you got different answers. And so you should know from last time that that means that the two-sided limit does not exist. They have to be the same, otherwise it doesn't exist. And to cap this off now with 12, 12 is not a limit question. 12 is a functional question. Let me change the pen here to emphasize this. So this is saying f of 0. So when the input 0, what's the output? Well, that's when I look for the hole, and not the hole, the dot, the colored in portion. All right, that's right there. So because there's a dot there, when the input is 0, the output of this function, all right, is going to be 1. If this open circle here, if that would have been filled in, and this would have been open, none of the limits would have changed, but then the functional value would have been 3. If both of these would be open, none of the limits would have changed, but then the functional value would have been not defined. Okay? All right, lastly here, let's do the same thing I did last time. Let's erase to clear some of this up. Nope, not pen. We want to erase. There we go. And this is kind of a neat question. Hopefully this one isn't too confusing. All right, so let's look here. It says, all right, let's add to the above graph by placing a point at 3, 2 and redo questions 5 and 6. All right, so I'm going to come up here and I'm going to put dot at 3, 2. All right, so now we're saying this is the functional value here. All right, so this is part of the graph now. So when the input is 3, the output is 2. How does that change question 5 and question 6? Well, let's do 5. limit of f of x is x goes to 3. So the limit of f of x is x goes to 3. As x goes to 3, right? Remember 3 is right here. As x goes to 3 from the right side, what's the corresponding functional values approaching? And as x goes to 3 from the left side, what's the corresponding functional values approaching? Now, before there was no dot here, the answer was -1. Now that I've put a dot there, I want you to pause the video and answer the question. What do you think the answer is? Let's be honest. You have two guesses. You're either going to say -1 or you're going to say 2. All right. Hopefully you paused it and you gave it a shot. And hopefully you said nothing changes. It's still -1, right? This functional value, remember, functional value has nothing to do with the limit. It has nothing to do with what these little bugs that are tracking on the curve are going to approach to. All right. So I'm still approaching -1. As x goes to 3 from the left, I'm approaching this y value. As x goes to 3 from the right, I'm approaching this y value. That did not change. The limit's still -1. So then what did change? This changed, right? The functional value now at x equals 3, there is an actual output. It's going to be that. So it's going to be 2, as opposed to before, there was nothing there, so it was not defined. All right, so there you have it. Nice and quick, doing limits graphically. See you soon.